In the relentless race for technological supremacy, the world's attention has now turned to a remarkable transformation happening in China's chip manufacturing industry. But can China truly break free from the constraints of lithography machine dependency and become a global leader in this critical field? Stay tuned as we unravel the fascinating journey ahead. Chips hold significant importance in our daily lives, being present in mobile phones, computers, and even washing machines. However, the production of chips relies on the use of a lithography machine, with finer chips necessitating more advanced fabrication processes. While China possesses strong chip design capabilities, such as Huawei High Silicon, it currently depends on other countries for lithography machines, primarily due to restrictions imposed on the Netherlands ASML by the United States. This situation has led to limitations in chip manufacturing within China. Nevertheless, there are reports suggesting that China has developed chip manufacturing technology that eliminates the need for a lithography machine. This raises questions about why lithography machines pose a challenge in China and how China should address this issue, along with considering the implications of the new chip manufacturing technology. An executive from ASML once stated, "Even if you provide Chinese engineers with the blueprints, they may struggle to construct an EUV lithography machine." It's not a trivial matter. Despite having access to the technical drawings, China might face substantial difficulties in building a lithography machine. These machines represent the most expensive component of semiconductor manufacturing equipment, accounting for approximately 25 to 30% of the cost. Additionally, it's essential to understand that producing lithography machines is not solely reliant on core technologies, but also demands a robust supply chain. Consequently, this sheds light on the reasons behind the ASML executive statements. However, becoming an industry leader cannot solely depend on ASML. An equally crucial factor is the ability to seize opportunities and demonstrate a willingness to innovate. ASML's greatest advancements occurred during the transition from the 193 nanometer to the 157 nanometer process. Traditionally, lithography machines followed the dry method, supporting technological progress by adopting more advanced exposure light sources for higher resolution. The wavelength of these light sources evolved from 365 nanometers to 248 nanometers, and then to 193 nanometers. Yet, as the technology advanced further, this path became increasingly challenging. Most companies chose to enhance existing technology routes. For instance, industry giants Nikon and Canon attempted to develop light sources with a 157 nanometer wavelength, but faced obstacles. During this period, a groundbreaking concept emerged: immersion technology. Many believed that it was overly complex and costly to implement. However, ASML took the risk and pioneered immersion technology, ultimately succeeding. Nikon and Canon's misjudgment not only resulted in significant losses in R&D investments, but also their defeat in competition against ASML. ASML's success can be attributed not only to its cutting-edge technology, but also its ability to seize opportunities and embrace innovation. As for the current state of China, can it replicate ASML's success? The answer is no. Every success story is unique and cannot be duplicated. However, in today's dynamic and ever-evolving landscape, change is constant, and the same holds true for EUV lithography machines. Following the constraints placed on Huawei, various countries have come to recognize the significance of core technologies and independent research and development, R&D. Consequently, European nations, Japan, South Korea, Russia, and others have embarked on a path of independent R&D for lithography machines, aiming to break ASML's monopoly. Manufacturers like Kioxia and Canon have successfully circumvented ASML, monopolizing EUV lithography machine technology and introducing the NIL process. This process allows for the production of 5 nanometer chips without relying on ASML's EUV lithography machines. Moreover, NIL technology holds the promise of significantly reducing production costs, with expectations of a 90% reduction compared to EUV lithography machine production costs. As a consequence, ASML is poised to face substantial challenges. Its association with the United States in blocking China has garnered global attention, creating potential risks for any manufacturer contemplating collaboration with ASML. Furthermore, emerging technologies are now capable of bypassing the need for EUV lithography machines. There is even talk of utilizing NIL technology to mass-produce 5-nanometer process chips by the year 2025. As European countries, Japan, South Korea, and China continue to make significant investments in semiconductor research and development, there is a growing potential to break the monopoly of EUV lithography machines. Rather than solely relying on packaging processes, these nations are exploring alternatives that may eventually replace EUV lithography machines for mass production. China, in particular, has made substantial advancements in chip manufacturing technology. As Wang Chuanfu, CEO of BYD, aptly put it, chips are man-made, not gods. The wake-up call from the United States has prompted a renewed emphasis on independent R&D. It is believed that with increased domestic investment in research and development and a commitment to innovation, Chinese manufacturers can overcome current challenges in the near future. China's efforts in lithography machine technology research have reached an intermediate level. The production of mid-range lithography machines is on the verge of scaling up, indicating China's mastery of the essential technologies required for these machines. Furthermore, research on EUV high-end lithography machines is in progress. According to reports, the Chinese Academy of Sciences has installed the first domestic high-energy synchrotron radiation light source equipment, enabling the production of high-end process chips. Additionally, the delivery of linear low-lens coating and nano-focusing lens coating devices to Shanghai Microelectronics Company Limited has eased the pressure on lithography lens manufacturing. Tsinghua University has achieved a significant milestone by completing a new particle accelerator light source called Stable Microbunch. This light source has direct applications as a primary light source for future EUV lithography machines. In recent developments, China's Chip Union Technology has unveiled a 3D4 F² DRAM architecture technology based on high-top technology. This innovative chip manufacturing method does not rely on EUV lithography machines and is designed for the production of DRAM chips. It represents another avenue that bypasses the need for EUV lithography machines. Not only can this technology overcome patent barriers in traditional DRAM design and manufacturing, but it can also substantially reduce production costs, thus avoiding the constraints imposed by international manufacturers. Taken together, these advancements in chip technology signal a crucial turning point in China's pursuit of independence from lithography machine restrictions. If these technologies mature as anticipated, China's chip manufacturing will break free from these constraints. These cases demonstrate that China is actively and determinedly pursuing the development of lithography machines, yielding significant accomplishments. Against the backdrop of global efforts to advance lithography machine technology, China possesses the capability to create its own lithography machines. The greater the challenges, the stronger the drive for innovation. China has a rich history of overcoming obstacles, exemplified by achievements like 2 bombs and 1 satellite, shield tunneling machines, subsea immersed tube technology, beta satellites, and 5G technology. China's progress has evolved from a position of limited advancement to playing a leading role in various domains. What role do you believe China will play in shaping the future of this industry? Feel free to share your thoughts and perspectives in the comments section below. Don't forget to become a part of the RlD Discovery community by hitting that subscribe button to stay informed about the latest technological advancements and innovations. Remember, as we delve into the realm of technology, the possibilities are limitless, and the future is filled with exciting discoveries. Keep exploring.